Okay, so we're practicing for the big quiz on all kinds of really difficult factoring tomorrow. This kind is rational root, where we got to use the rational root to figure out what possible factors we have when you have a 5 or a 6 term beast that you got to deal with. If it was 4 terms, I'd do factor by grouping, but on this kind, these are all the possibles. I'm going to have you check one, just check any one of those with synthetic and see whether it works or not. All right, I'll pause for a second. Okay, so what's one that you tested that worked? Got 4 or 5 lucky, 6 lucky people that got one that worked. Oh, 7 or 8, okay. Mr. Roach, what did you test that worked? -2 worked. All right. Now, if I actually have this one already done on the next slide, so I'm gonna not do this one for you because it's shown on the next slide. I'll try, what's the other one that somebody tried that worked? Yes, tried 4 and it worked. Okay, I'm gonna show 4. So I go look through and make sure I have a constant for each is 4 and 3 and a 2 and a 1, and this one's a plain constant. Why did I just check that? Why do I have to do that when I'm doing synthetic? Placeholders. If you forget that there isn't a 4, 3, 2, 1, if there's one of those missing, you have to have a placeholder for it. It's easy to forget, and it happens on your homework. Some kids will be like going through their homework today, and they're like, this isn't working. It's because you need a placeholder. Okay, 1, 4, -12, -6, 64, and -64. And I'm just double checking this actually works. 4, add them, multiply them, add them, multiply them, add them. 24, this isn't, where did I mess up? Where is there a 6? There should be a 16. Oh. Okay, thank you. And then the 16 times the 4 makes 64, and it worked. Okay. Now, it's going to just be luck which number, whether you pick the right one or not, except in one case. What if they're all positive terms? What did you learn about that? Then this number here would have to be a negative to make it work. Okay, so that's the one hint I can give you. All right, so here's the one that's all worked out for the -2. And on this one, even though you may not have tried this one, if you had done this one, you need to be able to interpret this and tell me what factored form you'd get out of this. So like this part right here gives you x plus 2. Remember that? And this part right here gives you, I'd like you to interpret that right now on your piece of paper. Okay, hopefully you said that that's just a normal -32. That is a -16x, and that is a 2x squared positive, and that is a x to the 3rd. So can you just stop there? No, because it's a 4-part one, and you'd have to do synthetic, no, excuse me, what does 4-part for us? Factor by grouping. I'd like you to try that right now. On this one you just interpreted here. This one will factor by grouping. Okay, for the few people that don't remember how to do this, you got to start by dividing it in 2 parts and just factor the first part. X squared goes into both of those, and you'll end up with x plus 2. What goes into both of these? -16, and so then I can factor out a x plus 2. And that needs to match that, and if it does, I can factor it out to the front. So that goes out here, x plus 2, and what's left behind is this, and that goes in there. X squared minus 16. Factored form? No, got to keep going. X squared minus 16 can keep going. So I got to go x plus 2 and x minus 4 and x plus 4. All right, good. Now, how many roots does this thing have? 3. What kind are they? Real. Now, there's supposed to be 3 roots, and there is 3 roots, and that's all good. I think it's right. Oh, I see what you mean. So this one is all factored all the way, and that's all good, but on the slide before this, we had this part. You're right. So this was actually an even bigger problem. So I need to bring that down, because what we just finished was this part right here. Now I got to bring that x plus 2 in. Thank you. So there's another x plus 2 here. And then that works because that adds another root, which makes it a 4-root animal. So if I go back to this one, and actually be even farther back, this one had 4 roots in the original problem. Thanks for catching that. All right. So now, one more factor by grouping. Try this one. Okay, so there's a good start. You group the first part and the second part together. And then that's in common, comes out to the front. And this is left over. Now I would ask you, is that factored all the way? Do you think you can go farther? So some people seemed like they thought we could go farther, but they're deciding maybe we can't go farther now. If that had been a 4, could we go farther? Yes, because then we could do that difference of square things, but we can't in this case. So since that's our fully factored polynomial, we can now look at the solutions. All right. And typically there's some real and some imaginary. All right. What's the solution for that one? -7. And really why that's -7 is because x plus 7 equals 0 is what you start with. You want this whole thing to equal 0. And then you subtract 7 from both sides. You get x equals -7. So we can do the same thing here. X squared minus 2 equals 0. And this is where a lot of times you'll end up with your imaginary roots. Is this one going to come out to imaginary roots? And some yeses and some nos. All right. If I add 2 to both sides, I'll have x squared equals 2. And then all of a sudden, I don't have a square root of a negative. So my absolute value of x is square root of 2. So x equals plus or minus square root of 2. I ask you, is that real or imaginary? Real, because there's no negative underneath the root. And there's no I. So that's real. It's when you have a problem like this that you'll have a real and a couple imaginaries. This one's real. What is it? 4. And this one's imaginary. Please set that up and solve for me right now and reduce it too. It'll simplify a little bit. So solve that. I should not really have written equals there. Solve this. Show me that you know how to do the imaginaries. All right, I bet a fair number of you have that. Is that the final answer? No, because why? Because the 8 can go farther. All right. And there's the actual final answer. All right, so let's take up a little room if you're going to show all your work. Raise your hand if you had that one right. Okay, good. That's imaginaries. Moving on to the next topic. These are the things that are on the quiz that we can just kind of talk over briefly. The one I put in the box is not factor by grouping. Try one of those. Okay, so on this one, we don't do factor by grouping here. We actually just use normal factoring. But we don't start with an x and an x. We start with what? X squared and an x squared. And then I need some number here that will multiply to 16 and add a -10. -2 and -8. I think you're right. Okay. So let's go with -2, -8. Now let's say that you had a really nasty boss and he just ripped you to pieces every time you were wrong on something. You'd probably start checking things first before you brought it to your boss. How could I check this to be absolutely positive it is factored right? Yes? Yeah, just multiply it out again. So I do my first, that's x squared. My outside is -8x. My inside is -2x, makes -10x. And my lasts is those two, makes +16. So it worked. Okay. Okay, so here is our last set of things that you have to know for the final, or for the quiz tomorrow, I mean. Long division, and synthetic division, and rational root theorem. And that's all the time I have on my video.